on the cognition side is where the leap seems to happen with humans. That it does seem we're kind of special. And that's a really interesting question when thinking about alien life or if there's other intelligent alien civilizations out there, is how special is this leap? So one special thing seems to be the origin of life itself. However you define that, there's a gray area. And the other leap, this is a very biased perspective of a human, is the origin of intelligence. And again, from an engineer perspective, it's a difficult question to ask. An important one is how difficult is that leap? How special were humans? Did a monolith come down? Did aliens bring down a monolith, and some apes had to touch a monolith for it to get it?
It's a lot like Descartes' idea, right?
Exactly. But it just seems that it seems one heck of a leap.
Yeah.
To get to this level of intelligence.
Yeah, and so Chomsky argued that some genetic fluke occurred 100,000 years ago, and just happened that some hominin predecessor of current humans had this one genetic tweak that resulted in language.
Yeah.
And language then provided this special thing that separates us from all other animals. I think there's a lot of truth to the value and importance of language, but I think it comes along with the evolution of a lot of other related things related to sociality and mutual engagement with others, and establishment of, rich mechanisms for organizing and understanding of the world, which language then plugs into.
Right. So it's language is a tool that allows you to do this kind of collective intelligence, and whatever is at the core of the thing that allows for this collective intelligence is the main thing. And it's interesting to think about that one fluke, one mutation could lead to the first opening of the door to human intelligence. Like all it takes is one. Like evolution just kind of opens the door a little bit, and then time and selection takes care of the rest.
There's so many fascinating aspects to these kinds of things. So we think of evolution as continuous, right? We think, oh, yes, okay, over 500 million years, there could have been this, relatively continuous changes. And, but that's not what anthropologists, evolutionary biologists found from the fossil record. They found, hundreds of millions of years of stasis.
Yeah.
And then, suddenly a change occurs. Well, suddenly on that scale is a million years or something, or even 10 million years. But the concept of punctuated equilibrium was a very important concept in evolutionary biology. And that also feels somehow right about, the stages of our mental abilities. We seem to have a certain kind of mindset at a certain age. And then at another age, we look at that 4-year-old and say, oh my God, how could they have thought that way? So Piaget was known for this kind of stage theory of child development, right? And you look at it closely and suddenly those stages aren't so discrete and the transitions, but the difference between the 4-year-old and the 7-year-old is profound. And that's another thing that's always interested me is how something happens over the course of several years of experience where at some point we reach the point where something like an insight or a transition or a new stage of development occurs. And, these kinds of things can be understood in complex systems research. And so evolutionary biology, developmental biology, um, cognitive development are all things that have been approached in this kind of a way.
Yeah. Just like you said, I find both fascinating those early years of human life, but also the early like minutes, days of from the embryonic development to like how from embryos you get like the brain, that development again from the engineering perspective is fascinating. So it's not so the early when you deploy the brain to the human world and it gets to explore that world and learn, that's fascinating. But just like the assembly of the mechanism that is capable of learning, that's like amazing. The stuff they're doing with like brain organoids, where you can build mini brains and study that um, self-assembly of a mechanism from like the DNA material. That's like what
Mm,
the heck?
mm.
You have literally like biological programs that just generate a system, this mushy thing that's able to be robust and learn in a very unpredictable world and learn seemingly arbitrary things or like a very large number of things that enable survival.
Yeah. Ultimately, that is a very important part of the whole process of, understanding this sort of emergence of mind from brain kind of thing.
And the whole thing seems to be pretty continuous.